Hello, this is Mrs. Huntley. You are in Module 4, Lesson 25, and I'm not on the right page of my module, so let me check where you should be. You should be on page 132 of your module. Lesson 25, Geometric Interpretation of the Solutions of a Linear System. That is a mouthful. Your essential question is much easier to understand. How do you solve a system of equations using graphing? Now, you might have noticed we skipped lesson 24. Lesson 24 was an introduction to systems of equations, but the introduction was, in my opinion, kind of confusing using some problems that were very difficult to understand. So we chose to skip that lesson for the time being. We might come back and pick it up after we learn a little bit more about it, but the essential learning that you needed from that previous one, we need to add in somewhere. And the only page that I can find some open space for notes is on page 137. So if you'd flip to page 137 and take some notes at the bottom of the page, that would be awesome. So a system of equations, what is it? It's two or more linear equations that we solve simultaneously. Now the word simultaneously means at the same time. So we're going to be doing two things effectively at the same time, or finding solutions for two equations effectively at the same time. The correct notation for a system of equations is using a bracket. So we're going to use a bracket like this, and the equations would go inside. Say we have y equals 3x plus 2 and y equals 4x minus 3. So our challenge would be to find the values for x and y that make both equations true at the same time. That's our goal. So the point that we find, that x and y value that is going to make both equations true at the same time, is called the solution to the system. So those are the main points out of the previous lesson that you needed to pick up, and hopefully this is making some sense to you, and we're going to work through some problems learning how to solve systems of equations using graphing, and then we're going to learn two other methods in this particular unit. So first we're going to start with graphing, then we'll do some substitution, and finally we'll do elimination, and of course some story problems and other application type of things. So finish taking these notes. If you need to pause the video, go ahead and do that. Otherwise, I want you to flip back to the first page in this section, which is page 132, and we're going to work through some problems together, and then I will release you to be working on your own as well. So page 132, hopefully you have the EQ down, and we have two equations here. It says sketch the graph of the linear system on a coordinate plane. 2y plus x equals 12 and y equals 5/6 x minus 2. So we have two equations in two different formats. The first one is in standard form. Now we have a couple of options when we come up to something on standard form. We could convert it into slope-intercept form, or we could solve it using the intercepts. I'm looking at this. It's not a super easy conversion because we do have a coefficient with our y, so it would require moving our y and dividing, or moving our x and dividing. So what I'm going to suggest is that we just solve it using intercepts. And for those of you that need a refresher, I am going to walk you through this first problem. So we've got 2y plus x equals 12. I'm going to first set x equal to 0 and solve for y. So 2y plus 0 equals 12. Just 2y equals 12. I need my y by itself, so I'm going to divide by 2, and y is going to equal 6. So when x is 0, y is 6. Now I'm going to set y equal to 0. So 2 times 0 plus x equals 12. 2 times 0, of course, is 0, so we just are left with x equals 12. So when y is 0, x is 12. So I am going to graph this equation. You know what, I forgot to mention, I mentioned it the two other times I recorded this video, but I forgot at the beginning of this video. If you have two colored pencils, that would be awesome. It's kind of nice to color code and have one equation in one color and the other equation in the other color. It just kind of makes understanding your graph a little bit easier. And these numbers, again, super hard to see, and especially being that I have bad glasses. Let's see, 9, 10, 11, 12. This is going to be 12 here. The other thing that you're going to need throughout this lesson is a straight edge. You're going to want to make sure that your lines are nice and straight because we're relying on the lines to tell us information about the solution to the system. So if you don't have a ruler, use your ID. If you don't have your ID, you're going to want to make sure you have something that's going to give you a nice, sharp, straight line. So for the other equation, so that's the first equation. It's graphed, all done. Nothing's new so far, right? We're not doing anything that we haven't done for the last several weeks. Now we're going to do the other equation. I'm going to switch to blue. And this other equation is in slope-intercept form. Y equals 5, 6, x minus 2. My y-intercept here is negative 2. So I'm going to go on my y-axis to negative 2 and plot that point. My slope is 5, 6. So I'm going to go up 5, 1, 2, 3, 4, 5, and then right 6, 1, 2, 3, 4, 5, 6, and make a dot. I'm going to do it again. One, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, and then I'm going to draw my line. And this line I want to be blue. So we have two nice straight lines. Now let's answer the questions that come below. Name the ordered pair where the graphs of the two linear equations intersect. So where are they crossing? You know what, I'm going to erase these dots. I put the dots on there so you can see what I'm doing when I'm counting, but they really don't exist on the graph. So we want the address of this point. What is the x, y of that point? So x is 1, 2, 3, 4, 5, 6, and y is going to be 1, 2, 3. I counted those because, guys, I can't see these numbers. I need new glasses, and then those numbers are so tiny, I couldn't see them, so I just counted the lines. The next part says verify that the ordered pair named in part A is a solution to the first equation. So 2y plus x equals 12. What does that mean? I'm taking my x and my y and I'm plugging them in. I'm substituting them into the original equation to make sure that it works in the equation. So 2, instead of y, I write 3 plus 6. Does that equal 12? 2 times 3 is 6 plus 6. Does that equal 12? 6 plus 6 is 12, and 12 equals 12. So that's a good solution for the first equation. The second equation, y equals 5, 6x minus 2. Again, I'm going to substitute in my x and my y values. I'm going to switch colors so it doesn't get too confusing. I'll switch back to blue since I did that. I should have done that top one in green. Sorry about that. Let's see, 3. Does 3 equal 5, 6 times 6 minus 2? Okay, 5, 6 times 6 is going to be 5. So I've got 5 minus 2 on the right side and 3 on the left side. 5 minus 2 is 3. So 3 equals 3. Good. It works in both of the equations. Using my x and y values in both equations makes both sides of the equations equal to each other. So part D says, would the point 4, 4 be a solution to the system of linear equations? So let's find 4, 4. Let's go purple. It's a color I haven't used yet. 1, 2, 3, 4, and then up. Now the point 4, 4 is only on the green line. It's not on the blue line. So remember when we were just dealing with one line, we said in order for it to be a solution to the equation, it had to be on the line of the equation. So I know the point 4, 4 is going to make this equation true, but it's not going to make this equation true. Because it will not work in one of the equations, it is not a solution to the system. So the point 4, 4 only solves one of the equations. A solution to a system of equations would need to solve both of the equations at the same time. Therefore, 4, 4 can't be considered a solution to the system, even though it solves one of the equations correctly. Okay, hopefully you've got all of that down. Hopefully this is not like bending your mind too much, because it's really not that different from what we've been doing. It's just adding another line onto the graph, figuring out where they cross, making sure that that point that they cross works in both of the equations. Let's do this one. Sketch the graph of the linear system on a coordinate plane. And again, we have two equations. The first one is x plus y equals -2. The second one is a typo. It says y minus 4x, but it should say y equals 4x plus 2. So that equal sign did not get copied properly. Again, our first equation is in standard form. The second equation is in slope-intercept form. Now this is one of the equations. Our first equation would be super easy to flip into slope-intercept form. However, it's also super easy to solve using intercepts. I'm going to choose to just solve it using intercepts to give myself some practice of that. So I'm going to, again, do x and y values. You know what? I should change colors because, oops, I don't want to, I want to have each one have their own. So I'm going to do x plus y equals -2 in blue. And I'm going to set x equal to 0 and then y equal to 0. So when x is 0, 0 plus y equals -2. Y is going to be -2. When I set y equal to 0, x plus 0 equals -2. Okay, so x is going to be -2. I told you it was easy solving intercepts. So 0, -2 is right here, and then -2, 0 is right there. I'm going to get a line and connect those up. Got to make sure my line is blue. Okay, it is. Whoops. Got to move that line closer onto the points. There we go. And I'm going to make my arrows in both directions. All right, so my next one, y equals 4x plus 2, that's in slope-intercept form. So my y-intercept is 2, graph your 2. My slope is 4, so I'm going to go 1, 2, 3, 4, and right 1. Now my graph isn't tall enough for me to put a second point going up, so I'm going to go down 1, 2, 3, 4, and then left. Hang on a second, something's wrong here. What did I do wrong? Did I copy the equation wrong? Hang on. Okay, I figured out what I did wrong. Sorry about that, and I hope that you are writing in something that you can erase. When I rewrote the equation, correcting the typo, I wrote it incorrectly. So our equation should be y equals x plus 3. So our y-intercept is going to be at 3, and our slope is at 4. So I apologize. I know that's like a big error, and ordinarily I would stop recording and do it again, but being that this is my third time recording it, I don't want to. Please don't make me. Okay, so my y-intercept is at 3 and my slope is 4. So 1, 2, 3, 4 and right 1. And it's not tall enough for me to do it again, so I'm going to go down 1, 2, 3, 4 and left 1. And I can already see where that line is going to cross. I'm going to get some purple and I'm going to make, what happened? That's not what I wanted to do. See, now I'm making mistake after mistake, and you're probably thinking, yes, you definitely should start re-recording, Mrs. Huntley. Let's see if I can get a real purple line. There we go. Okay. Nice straight line. And my line goes in both directions. Okay, so what is the solution? That's the point where both lines cross. So this one is at -1, -1. and I'm going to take that point and I'm going to make sure, I'm going to verify that it works in both equations. So does negative 1 plus negative 1 equal negative 2? Negative 1 plus negative 1 is negative 2, and negative 2 equals negative 2. So it works in the first equation. Second equation, does negative 1 equal 4 times negative 1 plus 3? 4 times negative 1 is negative 4, plus 3 is negative 1. So negative 1 equals negative 1, so it works. Next, they're asking us, would negative 4, 2 be a solution? No. Negative 4, 2 only works in the second, or in the blue equation. And I said the purple line above. You can tell that I've done this before and I couldn't remember which color was for which equation. So it's the blue line. Now, if you didn't use blue for that line, don't copy that part of the note. It only works in one of the equations, and whichever color you used for that equation is the one that you should be referencing right now. Okay, one more. Sketch the graph of the linear system on the coordinate plane. Again, we've got both equations here in standard form. Neither one of the equations have a coefficient with the y. So these are super easy equations to convert into slope-intercept form. I'm going to do the first one for you, and then I want you to do the second one on your own and then be checking your work. So the first one, I'm going to go with green. So 3x plus y equals negative 3, and I want it in slope-intercept form, which is y equals mx plus b format. So I need my y all by itself on the left side of the equal sign. What is with it? This 3x. What's the opposite of 3x? That would be a negative 3x. Whatever I do to the left side of the equation, I've got to do to the right side. So I'm going to subtract 3x from both sides of the equation. On the left side, these guys zero out. I'm left with y equals. Now be careful here, guys. I cannot combine 3 and 3x, or negative 3 and negative 3x. They are not like terms. To be a like term, they have to have the same variable raised to the same power. So my right side of my equation is going to be negative 3x minus 3. My slope is negative 3. My y-intercept is also negative 3. So if I'm graphing this, I come down to negative 3, make a dot. I want to go down, 1, 2, 3, and right. I need one negative move. Down is a negative move. My graph isn't big enough for me to make another negative move. And again, I need to have my 3 points. I'm kind of like Sheldon knocking 3 times. So I'm going up, which is a positive move, which means I need to go left to have my negative move in there. Because I can go in either direction, I just have to make sure that I have one negative move to make sure that it is a negative slope on my graph. So let's do a line. Whoops, that's not what I wanted. I wanted the colors. I am really getting tired. Can you tell? I've done this 3 times. I know I said that before. I'm just a little bit bitter and sad right now. Okay, so that is the first equation. I put it into slope-intercept form and I graphed it for you. So I would like you to pause the video, put the second equation into slope-intercept form, graph it, then go ahead and verify it and make sure that everything works, and then come back and check your work. Okay, so there you have the line. I converted the equation into slope-intercept form. I graphed the line and named the ordered pairs where the graphs of the two intersect here at negative 1, 0. So now I'm going to verify that it works in both of the equations. So the first one, 3 times negative 1 plus 0 equals negative 3. 3 times negative 1 is negative 3 plus 0 is the same, so negative 3 equals negative 3. It works in that first one. Negative 2 times negative 1 plus 0 equals 2. Negative times a negative is a positive, so it's going to be 2 plus 0 is just the same. So 2 equals 2, and that works. Now 1, 4 is right there. And that is only the solution to one of the equations. So unless it's the point where the two intersect, it's not going to be a solution to the system. I need both equations to be solved at the same time. So that is going to be it for this video. I'm going long. I'm trying to keep all of them under 20 minutes, and I am pushing up against that right now. So I'm going to end this video here. I hope you have a good night, and see you in school tomorrow. Well, actually, I won't, but I'll see you soon.